Hi there, and welcome to another Papetti Math YouTube video tutorial where we are going to be finishing up our lesson on graphing systems of inequalities. If you're just joining us now, I suggest you go back to those first three exercises as they might be very important for your success in this one. Otherwise, we're good to go with exercise number 4, where we have not one, not two, but three inequalities that we're going to be graphing on this coordinate plane right here. Let's start. We have y is greater than or equal to -5. So y and a number. This is going to be a special type of line that we learned about in chapter 3. And this special type of line is going to be a horizontal line. And we know that because when it's just y and a constant, it's going to be a horizontal line that goes through the y-axis at the value of this constant. So we're going to go through the y value at -1, 2, 3, 4, 5. And we're going to draw a horizontal line there straight across at -5. Well, that's a line right there. We need to make this thing an inequality. So we want to know where y is going to be. It says greater than or equal to this. So again, it's greater than or equal to, so we drew a solid line. And now we want to know where it's going to be greater than. The y values are greater than up above this line, so we're going to be shading this thing upward. So excuse my messy shading. There we go. We have our lines, our shading lines. I'll put one more in here. Whoa, that's okay. It's good enough. They don't have to be exactly perpendicular. It just has to show that it's shaded, which it does right there. Okay. And again, let's label that because we're going to have 3 now. We definitely want to know which one's which. So this one's y is greater than or equal to -5. Our next inequality is x is less than or equal to 5. So again, we should know that x lines, when we have x and just a constant, those are going to be a special type of line. That's going to be a vertical line that passes through the x-axis at the value of that constant, which is 5 in this case. So we draw a point at 5, and it's less than or equal to, so it's going to be a solid line going up and down where x is equal to 5. And once again, there's our line right there. My video's in the way. I need to move my video over. Here we go. And we'll just continue that line down now. Okay, I'll redo that. So let's draw this vertical line up and down. There we go. That's much nicer. And we'll draw arrows. And now we're not looking at the y values. We've always looked at the y values where we're greater than or less than. In this case, it says x is less than. So we want to know where the x values are less than this line right here. So the x values are less than that line to the left of that line. So we're going to be shading this one to the left of this line. And once we shade that one, we can go ahead, we can label this one as x is less than or equal to 5. And finally, we have our last inequality, y is less than or equal to 2x minus 1. Phew, here's a normal looking one where we have a y-intercept of -1. And we're going to be going up 2 units, right 1 unit, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay. So then we're going to go down 2, left 1, down 2, left 1, down 2, left 1. Okay. So it says what? Oh, we're not even close to done yet. We have to connect these points with a nice solid line because, again, it's equal to. So this is going to be a solid line right here. We're going to put arrows on that solid line. And we're going to be shading this thing where y is less than, which is going to be downwards. We're going to shade this whole thing downward. So remember, a system of inequalities is 2 or more. So this is the first time we're seeing that or more part right here. So we have 3 separate inequalities, and this one is y is less than 2x minus 1. But how do these all work together? It says, what is the area of the figure enclosed by the solution set? So we want to take a look at where our area is of this figure. So the figure we should see is a triangle. This triangle, here's our hypotenuse of this right triangle right here. I'll just color this on down. And then our base of this triangle is going to be the y is greater than or equal to -5 line right here, because this is where all three solution sets intersect. And then we're going to have a height of this triangle to be this line right here, which is x is greater than or less than or equal to +5. So if we were to connect all three of our lines to make our solution set right here, here's our solution set. We want to find the area of that solution set. So what we're going to have to know is we're going to have to know our area formula for a triangle is base times height divided by 2. And we do know our base. It's going to be 1, 2, 3, 4, 5, 6, 7 units. We have to see what our height is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units, because we have to continue the pattern up to where those two lines would intersect. So it's going to be 14 divided by 2. And that's going to give me 7 times 14 divided by 2. And I believe our answer is going to be 49. We could check that out. So 7 times 14, yes, divided by 2 would give me a solution of 49. But be careful, we need units squared because area is square units. So our area is going to be 49 square units. So this problem was a little bit different because we were graphing not 2 but 3 inequalities on the same set and then finding an area of the enclosed figure, which is a problem you might encounter also in your study of Algebra 1. And if this video was helpful, please give it a thumbs up, and you're now ready for the final lesson in Chapter 4. We're going to be solving word problems dealing with systems of inequalities. Thank you for watching.